Hello, in this video I'm going to take a look at two numbers here and walk through a process in which we find all of the common factors of these two numbers, and then we will draw an area model using rectangles on this grid paper to show the distributive property and see how they relate to each other. So we might have two numbers that we're adding or subtracting together, so sometimes we'll see this like 18 plus 24, or 18 or 24 minus 18, or 18 minus 24 even. So how do we take those two numbers and show an area model that will demonstrate the distributive property? Well, in this case, let's first find our common factor. So off to the side, we'll do some math here. We got 18, we have 24. We're going to use our division technique, where sometimes we could divide up, or some people will divide down, but we're looking for very small numbers, as small as you can. Start with 2s and 3s and then divide by those. So we can divide these by 2. We have 9 and 12. We can also divide 9 and 12 by 3, and we have 3 and 4 as our two answers. So our common factors are located right here. These are the common factors, 2 and 3. So let's list these first. What are all of the common factors of 18 and 24? Here's our list. 2, I see a 3, and I also see a 6. Because, of course, we can multiply common factors to get other common factors. So 2 times 3 is 6. That's going to be our GCF right there. So I'll label that GCF. Our greatest common factor is 6. Do over. Okay, now we're going to use these common factors to draw pairs of rectangles that have a common side length of these common factors. So I'm going to begin with 2. I'm going to use these little small squares that you see on here. So there's 1, 2, and then I need 9 going this way. 2 by 9. So a 2 by 9 rectangle, that gives me an area of 18, which is our first number. And now I need to extend this out. I'm going to draw another rectangle that is connected to it. And this rectangle is a 2 by 12. I'm going to put the 12 right here. That gives us a rectangle with an area of 24. So there's our 18 and our 24. I have two rectangles that are connected, and they have a common side length of 2. And I see that right here. All right, now we're going to do the same thing with the 3. We're going to make a common side length of 3. So let's go 1, 2, 3. Now, what are the lengths of the two rectangles? Okay, so this one should be 6, right? Because we're looking for an area of 18. And the next one, to make an area of 24, how long is that one going to be? All right, there we have 8 right there. So that's our next pair of rectangles. Finally, we need to do the same thing with a 6. So I'm going to come over here. There's 6, and let's draw our rectangles now. 6 by 3 and 6 by 4. So there's our 18, and there's our 24. Right there. So we can see the distributive property here, because 18 plus 24, and let me just kind of write it here. 18 plus 24 is the total area of all those, and also we can see this, 6 times 3 plus 4. So 6 times 3 plus 4. We also see the same thing with a common side of 3, and that would be what would go inside the parentheses to multiply 3 by. We see those two side lengths, 6 plus 8. And we can also use the 2 and say 9 plus 12 is inside the parentheses, because those are the two side lengths of the rectangles. If we were to work all these out and find our answer, we would get the exact same answer of 42 right here. So this is 6 times 7, 42. 3 times 14 is 42. And then 2 times 21, here we go, 42. So same answer, same total, different ways of writing it. And that's it. That's how we can use area models to draw out the distributive property and to show that.